Okay, so this is the second example where all I'm going to do is set up the problem. Because again, that's usually the hard part. And this one's a toughie. This one's going to be a little different. Like, remember I said about 90% of the time, you're going to have x and y greater than or equal to 0. This is going to be one of the 10% of the time that it's not the case. Now, it still are values that are positive, but there's more to it. And we'll get into the application to explain why there's more to it. So this one actually is, again, we usually progress. We kind of give you a standard case in the first example, and this is sort of the harder case. Alright, first thing though is kind of read through the problem, and I'm going to take a highlighter and kind of highlight the important parts. So we have Jim. He builds two kinds of birdhouses, a standard model and a deluxe model. It takes him 2 hours to build a standard model and 3 hours to build a deluxe model. Alright, his materials for each standard model cost $10, and the materials for the deluxe cost $12. Suppose Jim can only work at most 48 hours on building birdhouses. He has a total of a budget of at most $210 of material. Jim also is guaranteed he will build at least 6 standard and at least 5 deluxe every week. He plans to sell his standard birdhouses at a price of $45 a piece, his deluxe birdhouses at a price so prices, maximum revenue. So the last kind of things goes with my revenue. Alright, so there's a whole lot that you have to unpack on this problem. There's the hours he can spend, there's the money he has to spend, then he's guaranteeing he's going to make at least 6 of the standard and at least 5 of the deluxe. And those are the last 2 examples of where we're going to get some of those inequalities from. And so again, there's a lot to unpack in this. And then he's going to sell them, right? So the standard birdhouse must be smaller, less to it. So he's got 45 of those, and $45 for each one of those, and then $60 for each one of his deluxe birdhouses. All right. So first thing is, what's the variables in the objective, and then we'll get to the constraints again. I'm just going to set this up. We're not going to solve it. And so I'm going to start with the variables in the objective. And so I'm going to let x be the number of standard birdhouses. And y is the number of deluxe. Birdhouses. Then his objective is to maximize revenue. So the objective function is he wants to maximize revenue, which I'm going to let be R. Alright, my maximum revenue. Alright, revenue, remember, is generated from price times quantity. So the price for every standard birdhouse is 45, so it's going to be 45 times X. And then the price for every deluxe is 60, and so 60Y, right? And so there is my objective, which again, I'd set that to the side, and we'll figure that out later. Again, this one's just setting up, but there's the setup. That is what we want to optimize. We want to maximize revenue generated from the sale of birdhouses. All right, so objective, which again is usually the easier of the two. Now the constraints, the inequalities. All right, so the inequalities come from the limited amount of hours, right? He has at most 48 hours to build it. His limited budget, right? He doesn't have bukus of dollars. He has at most 210 to spend on materials, and then he's got these at least. So I'm going to kind of write those down. So it's the green stuff I'm writing down first. So we have at most 48 hours to build. At most $210 to spend. And then we want at least 6 standard and at least 5 deluxe. so there are 4 inequalities that we're going to get. We'll start with the 48 hours to build. And so, first of all, at most, right? And it should just, the numbers should make logical sense. He has 48 hours to spend every week to build his birdhouses. That's your maximum, right? He could spend all 48 hours building them, or if he's efficient, he could spend less than that. And so this is going to be my equation, which is the building the birdhouses, can be less than or equal to the maximum, which is the 48 hours he can spend, right? So this is going to be the equation involving building the birdhouses, which there are numbers that go out of front that I'll have to figure out based on what they tell me in the application. But I know it's a less than, right? Comes out less than because he can't go over 48 hours, but he could go under if he wanted to. The same thing for the budget. He has to spend less than or equal to $210 a week. That's his max, right? He can't go over his budget. But if his materials go on sale, he could go less than his budget, all right? And so his building can be equal to 210 or less than 210, which again, the numbers out front I'll get from my equations. The last one is, and maybe I'll get to these because these are sort of the special cases. We'll get down to these in a second. I'm going to fill out my hours to build and money, so I'm going to do those first. All right, so looking at my hours, so I'm looking at the hours it takes. So remember, X represents standard, and so I'm going to go figure out, well, how many hours does it take to do my standard? And so that was all the way near the top. It takes 2 hours to build the standard and 3 hours to build the deluxe. So 2 goes with the X, 3 goes with the Y. So 2X and 3Y. Alright, and so that's the number of hours he can spend on each. That has to add up to 48 hours or less. Alright, now the budget, which I believe is the blue part. He can spend, the standard models cost him $10 to build, and the deluxe costs $12, so 10 goes with X, 12 goes with Y. So 10X, 12Y, and there's his budget, right? He can spend $10 for each standard, $12 for each deluxe. He can spend up to 210, but less. Can't go over it. Okay, so less than. Alright, so those are the two sort of kind of cases similar to what we did last time. Alright, now these at least 6 standard and at least 5 deluxe. And so remember, standard is the X, deluxe is the Y. And so what this is he's guaranteeing he's going to make at least 6 of these. So usually what you do is you have stores that you're going to sell them at, and you're telling them, well, I'll have at least 6 for you to display. All right, that's I'll at least have that many. I might have more, but I'll have at least 6 that I'm guaranteed that you can put in your storefront of the standard, and I'll have at least 5 of the deluxe. And so this involves only the X variable. My X, which represents the standard, will be at least 6. So at least 6 means 6 is my minimum X value. I can have 6 of the standard houses or more. And so X is going to be greater than or equal to 6. And then the same thing for the second one. At least 5 deluxe. The deluxe is the Y value. So I'm guaranteeing, or Jim is guaranteeing, he's going to have at least 5 every week of these deluxe. So he could have more, but at the minimum, he's going to have 5. So he could have 5s deluxe, so 5 of the Y values or more. And so it's Y is greater. And so this is why this is an example of where X and Y's aren't greater than or equal to 0. We actually have a little more to them. They've got to be bigger than 6 and bigger than 5. So I would go out a little further. Instead of my boundary being the X-axis and the Y-axis, my boundary for my feasible region would be at the line X equals 6. That would be my vertical line. And my horizontal line Y equals 5. And I'd shade everything below and to the left of those. And those would be, again, outside of my feasible region. And so that would be, so this is sort of the case where it's not greater than or equal to 0 because I've got to be bigger than some other number. All right, greater than or equal to 6, which guarantees I'll be bigger than 0, and greater than or equal to 5, which guarantees I'll be bigger than 0. So I don't have to put those 2 equations in it. And there is my setup, which then I'd go and solve that, which, like I said, I'm not solving it in this case. If you wanted to try to solve it on your own, you can. I was just practicing the setup because I believe the setup is the hard part. And I did kind of one straightforward example and one, this would be, I would consider this one a little more complex because of these last 2 parts. Alright, so that's the setup, and then after this we'll do videos and I'll do the whole thing. Setup, and solve. So we'll do those in the next videos.